Hello there, this is Reza Mashayekhi, and in this video we are going to have a look at the wireless mobile telecommunication technology journey from mobile radio telephone known as 0G in 1940s to the last generation, which is 5G. But we all know that the journey started many years before that, when Alexander Graham Bell invented and patented wired telephones in 1876. And even before that, when telegraph was first used in 17th century, having in mind that the real journey started many years ago, maybe in 400 BC on the Great Wall of China, by sending beacon fires or drum beats. Moving from wired telephone to wireless communication was a big revolution. This revolution was first called mobile radio telephone, but when next wireless generations got created, it was called pre-cellular or 0G. Pioneers for this big step forward were Motorola and Bell Systems, giving birth to 0G in 1940s. But what is the technology behind 0G? It first used push-to-talk. What is push-to-talk? When you press a button to speak and leave that button to listen to the other side is called push-to-talk technology. It then got improved and MTS, IMTS and AMTS were introduced, which gave full duplex support and higher voice quality. The telephones were too big to be carried normally by people. They were mounted on cars, putting the antennas, senders and transceivers at the back and the phone on the front side. After a while, the briefcase version of them came out, which was of course more convenient. Although 0G was a great change, it could not be used by everyone. Another big step forward was needed, and it happened not earlier than 1979. First generation of mobile telecommunications opened wireless doors to everyone. It was first commercially released in Tokyo, Japan in 1979 by entity Nippon Telegraph and Telephone, and in 5 years, Japan was the first nation fully wireless connected. In 1981, NMT system made 1G available in Denmark, Finland, Norway and Sweden. It also introduced the first international roaming. It let people in different countries speak wirelessly on the phone. In 1983, Motorola Dynacat mobile phones were first used in Chicago, the US. And then slowly all the world began experiencing wireless world. Talking about technology details, signals can be modulated either digitally or via analog technology. 1G used analog signals to transfer information. This information was only limited to voice calls, with a maximum speed of 2.4 kilobits per second for data transmission, which sounds funny nowadays. The very low frequency of 150 MHz was used, which led to a high coverage, but also high latency and battery consumption. The voice quality was not also very acceptable. That's why you could hear people shouting on the phones. 1G telephone could be carried and used by normal people, and at that time they even didn't look too big, but comparing to today's technology, they look like a joke. Having tasted the world of mobile technology, people felt the need for more. Over 10 years, technology also got advanced, and the outcome was 2G technology. The second generation of mobile technology was a big achievement, opening the doors to current advancements. 2G includes various standards, starting with GSM or Global Systems for Mobile Communication. It was first released in Finland in 1991 by Radiolinja now a part of Elise OH. The biggest change was using digital modulation instead of analog technology. It used TDMA and CDMA, or time division multiple access and code division multiple access, for multiplexing and 900 MHz frequency. These specifications enable the maximum speed of 14.4 kilobits per second both in downlink and uplink, giving the possibility to add SMS or short message service to voice calls, and also increase the quality of voice calls. You could see that people shout less on the phones. Mobile phones also got way smaller and more secure. This is the architecture of GSM networks, which is the base architecture of future mobile technologies. In the next generation, some elements were added or removed, and functionalities were modified, but the whole architecture is quasi-similar. According to this architecture, if a cell phone in, for example, one city wants to call another cell phone in another city, it first had to send information to the supporting BTS. A collection of BTSs were controlled by one BSC, which is a higher tier in GSM networks. All BSCs were orchestrated and controlled by the Mobile Switching Center, or MSC, which was responsible for managing the whole network and routing calls and messages between subnetworks. It used its own databases and intercommunications in order to receive those information. After the BTS forwarded the packet to BSC and then the BSC to the MSC, the MSC was responsible to find the BSC supporting the destination mobile phone. It forwarded the packet to that BSC and then that to the BTS connected to that phone, and then finally the destination phone receives the first part of data from the BTS. From now on, the connection is established between two phones, and the following parts of the data follow this path. It is also called the circuit switching paradigm. The symbol for 2G networks is the letter 2 and G together, which appeared on top of the cell phone screen when connected to GSM networks. The next 2G standard was GPRS, or General Packet Radio Service. It was first standardized and released by ETSI in 1993. The big difference here was the use of packet switching technology, where all information to be sent to the destination was divided into packets and all packets could be sent in parallel. This standard reached the maximum speed of 53 kilobits per second in downlink and 26 kilobits per second for uplink. This speed lets GPRS to introduce MMS, or Multimedia Message Service, which gave the user the capability to send media like pictures. It also supported IP to connect to the internet. In the architecture of GPRS network, mobile devices had to be equipped with GPRS modems, and the GPRS network also had a GPRS gateway towards the World Wide Web. The symbol for GPRS networks was letter G. The last 2G standard was Edge, which is also called 2.75G. It was introduced by AT&T in 2003, and the maximum speed was 236 kilobits per second for downlink and 59 kilobits per second for uplink. It used 8 PSK encoding, and the symbol for that was E. 2G technology introduced digital modulation and packet switching, which opened the doors towards high-speed connections. In less than 10 years, 3G was introduced in 1998, the third generation of mobile networks aimed at increasing network speed. The first standards of 3G were WCDMA and UMTS. 3G was first released in Japan by Entity in 1998, but it was not a commercial release. The first commercial release was in South Korea by SK Telecom in 2001. It used CDMA technology or code division multiplexes for multiplexing and followed packet switching paradigm using three main frequency bands of 850, 1900, and 2100 MHz. WCDMA standard was based on GSM, but UMTS was a new standard by 3GPP and was used mainly in Europe. The maximum speed depended on the device mobility. For moving devices like a mobile phone in the cars or on the trains, it reached the maximum speed of around 384 kilobits per second, while for non-moving devices like people on foods, this speed was around 2 megabits per second. Having a big increase in transmission speed, 3G introduced video calling, mobile internet, and streaming services. Another great change with 3G was that people did not pay based on time to use the services. It was possible to pay based on the amount of data transferred. The symbol for 3G networks was 3G. The third generation after a while introduced two other standards known as HSPA or 3.5G and HSPA Plus or 3.75G. HSPA was the enhanced version of WCDMA technology with the maximum theoretical speed of 5.76 megabit per second for uplink and 14.4 megabit per second for downlink. But in practice, this speed was around 200 kilobit per second and 500 kilobit per second for uplink and downlink respectively. The symbol for HSPA was letter H. HSPA Plus was the evolved version of HSPA and used MIMO, which is the acronym for multiple input, multiple output. It used more than one antennas for sending and more than one antennas for receiving data. It drastically increased network speed to a theoretical value of 22 megabit per second for uplink and 168 megabits per second for downlink. The symbol for that is H+, which is also seen now sometimes when 4G network is not available. Since the introduction of 3G technology, effort has been on increasing data transmission speed, quality, and security. A very dramatic step towards that purpose was 4G technology. The fourth generation of wireless technology is also known as LTE. The standardization of LTE started in 2004 by ITU. And in 2005, LTE specification was released and the deployment process started. In 2009, the first commercial release of 4G LTE networks was available in Oslo, Norway and Stockholm, Sweden. But 4G was not only LTE, it also included another standard named WiMAX, which was standardized by IEEE, and the standard was called IEEE 802.16. It was released in June 2006 in South Korea. However, LTE was the winning 4G technology. The symbol was 4G or 4G+, which you may now see on your phone, of course, if you are not connected to a Wi-Fi network. 4G technology, as mentioned before, has two main standards. Here we focus on LTE, which is the most useful one. LTE is fully packet switched based on IP or Internet Protocol. It uses orthogonal frequency division multiple access or OFDMA and MIMO multiple input multiple outputs. The maximum speed of 4G technology, depending on the standard, varies. For LTE, download speed goes up to 100 megabit per second, and for uplink, it goes up to half of the download speed. LTE Advanced can reach the maximum download speed of 1 gigabit per second, while this value is around 500 megabit per second for uplink. For WiMAX, however, the maximum download speed doesn't go more than 128 megabits per second. LTE supports a very big range of frequencies, from 7, 8, 900 to 17, 18, and 1900s, or even to 21 and 2600 MHz. This frequency range and IP packet switching have made data transmission possible with low latency. Having high speed and low latency, LTE supports a big variety of use cases such as IP telephone or voice over IP, 3D television support, video conferencing with multiple active participants, easy and fast mobile web access, HD mobile TV, online gaming, and even cloud computing. At that time, people thought they have what they need from mobile telecommunication networks. But soon, with new technology ideas such as IoT or Internet of Things, smart cities, and massive sensors, driverless cars, and even remote surgery and operations, the need for a more advanced wireless technology showed up. 5G is thought to be the solution for all the mentioned targets. It uses a new radio standard for air interface, and it is supposed to be released in 2020. Some test versions are being deployed all around the world, but it is not yet commercially released. It uses time division duplexing instead of FDD or frequency division duplexing, and it allocates one time slot for uplink per each 3 downlink time slots. The big changes in comparison with previous technologies are beamforming and massive MIMO. It uses a very wide frequency range, and it is the first time that 5G has introduced various standards for different use cases. But before talking about use case categories, let's get to know some principal technology details. 5G uses beamforming to achieve spatial selectivity. In more conventional networks, antennas used to transmit data in all directions, and all devices in a cell would receive data for a specific device, and based on address information and packet headers, each device collected its own data. In beamforming, antenna arrays are used, and signals are sent in particular angles. Using background messages between antennas and devices, antennas understand where each device is located at any certain time and send information related to that device only using the beam towards that device. In this way, data transmission experiences a higher speed and quality. 5G also uses massive MIMO. It uses a large set of antennas to send and receive signals, which dramatically increases throughput and reliability. But having all these benefits and features, 5G is not a single standard. Nowadays, data transmission and telecommunication is used in different areas with different needs. For some use cases, the amount of transferred data is critical, while for some others, latency is the key issue. For some scenarios, a massive number of devices has to communicate, while in some cases there are fewer devices, but they need a very high data rate. 5G has divided all these use cases in 3 different categories, namely eMBB or Enhanced Mobile Broadband, where the amount of transferred data is high, MMTC or Massive Machine Type Communication, where the number of devices needing network access is high. And finally, URLLC or Ultra Reliable and Low Latency Communication, where latency and reliability play the key role. Examples for eMBB is HD videos or 4K videos and video conferencing. For MMTC, we can name Smart City or massive number of sensors in a field. And for URLLC, we can name Smart Logistics and driverless cars, where microseconds matter. For each category, requirements are mapped. List of requirements include data rate, traffic capacity, energy efficiency, density, latency, and mobility. According to each category needs, corresponding services and standards are getting prepared. Finally, let's take a look at 5G frequency range. The whole range includes 400 MHz to 1 GHz frequency, then the 6 GHz frequency, and finally 30 GHz or 60 GHz frequencies. The two left ones are called sub-6 frequencies, and the rightmost one is called millimeter wave. The smaller the frequency, the higher coverage is available, but it gives less capacity and speed. Band size for small frequencies is around orders of 10 MHz. For 6 GHz, band size is an order of 100 MHz, while for millimeter waves it goes up to 1 to 2 GHz bands. Cell size is also very big in low frequencies, but it decreases to millimeters or centimeters in 30 or 60 GHz frequencies. That's why they are called millimeter waves. Lower frequencies are used for cases like eMBB or IoT, while higher ones are used for driverless cars or smart cities. This was an overview of wireless technology from car-size analog phones to high-tech advanced 5G phones and networks of today. It is very difficult now to predict what 6G is going to be like, but we have to wait and see. In order to keep updated with new technologies and learn more, don't forget to subscribe to Vision Academy and give us thumbs up to encourage us to create more videos. Have fun!